Swayam Prabha. Digital India. Educated India.
So now let us see, in fact, now that you have asked this, let us see if there is any conflict in the two. Okay. So then this here Q1 star star, we got this from a certain set of reasoning, which is gamma 2 star star and Q1 star star. Question is that a Nash equilibrium of this game? So let us check that. So is Q1 star star comma gamma 2 star star a Nash equilibrium? So is this a Nash equilibrium? What do we need to check for it to be a Nash equilibrium? We need to check these conditions here, right, these conditions, which means that assuming player 2 plays gamma 2 star star, player 1 would want to stick to the quantity Q1 star star. Okay. Assuming player 2 plays the function gamma 2 star star, player 1 would want to stick to a quantity Q1 star star, and assuming player 1 plays the quantity Q1 star star, player 2 would want to respond with the function gamma 2 star star. Is this clear? That is what we need to check. Okay. So let us check that now. So let us look player 1 first. Okay. So player 1, so this is player 1 plays a quantity, suppose Q1, player 2 is going to stick to gamma 2 star star. Okay. So he gets a utility U1 of Q1 comma gamma 2 star star of Q1. Okay, this is the payoff of player 1 when he plays a quantity, some quantity Q1. So what he wants to do is then maximize this over Q1, right. So he is maximizing this over Q1. Now what is the quantity that maximizes this? It is Q1 star star itself, because Q1 star star was derived from this particular maximization itself. So Q1 star star maximizes is in fact the maximization of maximizing quantity here. That is by construction, because of the way we constructed Q1 star star. It actually is the maximizing thing here. Okay. Alright. So good. So one part is done. Now let us look at player 2. So this was for player 1. Now look at player 2. For player 2 we have to fix player 1's quantity at Q1 star star, and we are asking what is the function that player 2 responds with. Okay. So suppose player 2 plays a function gamma 2. You are maximizing this now as a function of gamma 2, and so you are maximizing this. So what is J2 of Q1 star star comma gamma 2? I need to put Q1 star star here and Q1 star star here. So what is this maximization, and what function maximizes this? Okay, but remember, so is there any other function that maximizes this? So let's take this very carefully. So remember, gamma 2 star star was derived by maximizing a different expression. It was derived by maximizing this expression, and here you have Q1, not Q1 star star. So which means gamma 2 star star was the function that maximized this U2 of that maximized this here for every value of Q1, because we got as a function of q1 we wanted to find the maximizer. Whereas now we are asking not for every value of q1, we are asking for a specific value of q1, which is q1 star star. See, compare that with this expression. Here there is only q1 star star that has been held fixed. So, fixing q1 star star, what is the function that maximizes u2 of gamma 2 of this? So, the point is, see, remember, when we are looking for a function of an arbitrary q1, it makes sense to ask for a function. Now, you are asking for the value of the function only at q1 star star, right. So, really what gamma 2 does at other values of q1 is irrelevant. So, any function gamma 2 hat or such that, or any function gamma 2, let us say any function gamma 2 such that gamma 2 of q1 star star is equal to gamma 2 star star of q1 star star maximizes I can choose any function so long as at q1 star star it agrees with the maximizing value that came from gamma 2 star star. Outside for the other values of q1, it does not matter, it can do whatever it wants, it will still maximize this objective, right. So, this has become like what has happened is it has become a degenerate function optimization, because you have fixed the argument of the function. Really you aren't you do not care about what the value of gamma 2 is at other values of q1, right. So, for example, if q1 star star was 100, what matters here is what gamma 2 of 100 is, not what gamma 2 of 90 is or 105 is. That does not affect this objective. So, all of these are maximizers, all these functions are maximizers. In particular, gamma 2 star star is also a maximizer. Okay. So which means that this is greater than equal to this. Since gamma 2 star star is also a maximizer, so I may as well take that, and that does satisfy this. Okay. So, you see there is a bit of degeneracy that has come up here, that after having played q1 star star, player 2 could have actually responded with any function. After player 1 has played q1 star star, player 2 could have responded with any function. So, keep this in mind, we will come back to this, we will come back to this again. Okay. So, what have we established then? We have established that this is a Nash equilibrium, okay, that q1 star star comma gamma 2 star star is actually a Nash equilibrium. So, the strategies that we got by doing some sort of mental calculation, kind of heuristic calculations, is in fact a Nash equilibrium of the game. Okay. But you can see there is the subtleties have already started emerging, that there is something else also that is going on here, that it is not as simple as just okay, this fellow responds, so then let me do this and so on. It is not only that, there seems to be more at play here. So, let us ask, okay, is there another Nash equilibrium, or can you think of another Nash equilibrium? Yes. Which is? No. Okay. So, this was the, this was the bait and you fell for it. So, you might think that, for example, I could just since there was so much flexibility here, to take any gamma 2, right? Can you take any gamma 2 really, and will that be still a Nash equilibrium? So, suppose I took gamma 2, some other gamma 2, which was not optimal for, so suppose q1 star star is 100, okay. I took a gamma 2 which is not optimal for 90, it is optimal for 100 but not optimal for 90. The question is then will that gamma 2 and q1 star star, which is 100, will that still be a Nash equilibrium? No. Exactly. See, it is still a best response to q1 star star. So, that other bogus gamma 2 that I just mentioned is still a best response to q1 star star, but q1 star star is not a best response to that. There is no guarantee. q1 star star is obtained by assuming q1 star star is player 1 plays q1 star star because player 2 is playing gamma 2 star star. It's optimal for, rather let me put it this way, the optimal quantity for player 1 to play is q1 star star when player 2 is playing gamma 2 star star. If player 2 decides to play something else, then the quantity for player 1 would also change. Okay. So, although there are infinitely many best responses here for player 2, you cannot, doesn't mean that player 2 can really pick whatever he wants. Okay. This happens again, we have seen this also in when there are finitely many strategies for the player, for each player. Yeah.
That's not true, right? Player 2 can play whatever he wants, but the Nash equilibrium is not. But the Nash equilibrium.
I mean, of course, that's, so whatever he wants in Nash equilibrium, it's obviously. So, this is something we saw even when there were finitely many, for when we are looking at mixed strategies, right. A player will have in general infinitely many best responses, but not all of them will actually constitute a Nash equilibrium. Okay, all right. So, then now tell me another Nash equilibrium. So, let us go back to the definition. This is what we are looking for. So, let us go back and see this. So, my contention is this is also a Nash equilibrium. Okay, but we have to interpret it appropriately. This here, remember this, what was this? This was the Nash equilibrium of the simultaneous move game, when players were deciding the quantities simultaneously. Now, player 2 is observing what player 1 is producing. Okay. Yet, I am saying that this one, which was this equilibrium of the simultaneous move game, is still a Nash equilibrium of the dynamic game. Okay. Let us see how that happens. Firstly, that equilibrium is mentioned in the space of quantities, right. So, I have to first produce for you an equilibrium in the space of strategies here. So, so let us first do that. So, my claim is that I am going to take, for player 1, I am going to still take the quantity that he was producing in the simultaneous game. For player 2, I am going to take a function gamma 2 star, okay, function gamma 2 star, and this is going to be a function of q1, but I will take it to be a trivial function. I will take it to be a constant function. Okay. So, gamma 2 star is defined like this. Gamma 2 star is a constant function equal to q2 star. What was q2 star? It is the quantity that player 2 would have produced in the equilibrium of the simultaneous game. It was 1 minus c by 3, that quantity. Okay. So, this is now this is identically equal to this. So, gamma 2 star is a constant function identically equal to q2 star. Is this clear? So, this I am going to claim this here is a Nash equilibrium of the dynamic game. It's a context, it's a equilibrium of the dynamic game, which means that it satisfies this.
Are we going to use the exact form of utility?
Yeah, it doesn't actually, may not even matter, but this is what is being going to be shown. Okay. So, that this is a Nash equilibrium of the dynamic game. Okay. So, again I need to check best responses. So, let us start with player 1. Suppose, okay. So, player 1, when he plays q1 star, and player 2 is responding with the function gamma 2 star. Okay. So, now what is the utility that he gets here? He is going to get the utility q1 star comma gamma 2 star of q1 star, right. But what is gamma 2 star of q1 star? Gamma 2 star is a constant function. So, this is equal to u1 of q1 star comma q2 star. Okay. All right. Now, suppose player 1, let us suppose player 1 played some q1. What happens to this? What is gamma 1 star of q1? It is still q2 star, because gamma 2 star is a constant function, right. So, irrespective of the value of q1, it is still going to produce the value is q2 star. So, this is still equal to q2 star. So, now you maximize this over q1, what would you get? You are effectively just doing the best response to the Nash equilibrium, simultaneous Nash equilibrium strategy of player 2, right. So, what is this? So, if you maximize this now over q1, okay, this maximizer here is q1 star. So, which means that if player 2 plays the constant function gamma 2 star, it is optimal for player 1 to play the quantity q1 star. Okay. So, which means player 2 plays the constant function equal in which the value is equal to the Nash equilibrium from the simultaneous game, then it is optimal for player 1 to also respond with his own Nash equilibrium from the Nash equilibrium component from the simultaneous game. Is it clear? Okay. So, this is done, we are done for, so for player 1 this is done. What about player 2? So, for player 2 we have now q1 star fixed, and player 2 is going to pick any function gamma 2, and the utility he gets is u2 of q1 star comma gamma 2 of q1 star. And now you are maximizing this over all functions. And like we had in the earlier case, the same thing, something similar is coming up here also. You can see, so like we had in the earlier case. So, what's the optimal gamma 2 for player 2 to play? It doesn't essentially, he can play any strategy so long as at any gamma 2, so long as at q1 star it is equal, it corresponds to the best response, simultaneous best response to q1 star, right. So any gamma 2 such that gamma 2 of q1 star is equal to q2 star is optimal, here is the best response, right. So, in particular you can take the constant strategy, the constant strategy which regardless of what the value of q1 is, always takes value q2 star is also a best response. So, in particular gamma 2 star, which is identically equal to q2 star, is also optimal, right. So, this is also optimal. So, in short, we've got that now for player 1 and player 2, we've concluded that this here, this is also a Nash equilibrium. Now, this is actually a very interesting and very general fact. You take the Nash equilibrium of the simultaneous move game, it will be inherited upon suitable interpretation as a Nash equilibrium of a dynamic game. So, let us understand what is happening in this. What is happening is in this sort of a game, in this situation is player 2 is basically saying So, okay, let's first interpret the earlier Nash equilibrium. In the earlier Nash equilibrium, what was player 2 doing? In the earlier Nash equilibrium, player 2 was responding optimally to every quantity that player 1 could have played. That was his strategy, right? Gamma 2 star star was a strategy which was optimal, which was an optimal response to which produced an optimal quantity in response to anything that player 1 produced. And then player 1 then chose his quantity, keeping this, sort of in response to this in particular. Is this clear? But in retrospect, with player 1 having played Q1 star star, player 2 could have played anything else, but then anything else would not have forced player 1 to play Q1 star star. Okay, but look at what's happening in this equilibrium. In this equilibrium, Q1 star and Q2 star, the single starred ones, are a very special quantities because they are Nash equilibrium of the simultaneous game. So what's happening here is player 2 is playing this constant strategy, saying which is always equal to Q2 star. So player 2 is basically saying, doesn't matter what quantity you produce, I am going to produce Q2 star, and he is picking a quantity equal to that which he would have played if in the simultaneous move game. So player 2, what he is doing is, although he has the information of Q1, he is playing as if he has no information, right? He is ignoring the information that he had. He has the information of Q1, but he is playing a constant strategy which makes no use of that information, but he is pegging his quantity at the level that he would have played in the event that he had no information. Now, in response to that, then player 1 is also sort of is compelled to play as if there was no information available to player 2. So effectively, this has also become a Nash equilibrium of this game. Now, there is something strange going on here, that in the earlier Nash equilibrium, in this Nash equilibrium, player 2 was guaranteed to respond optimally to every quantity that player 1 was producing, right? The action that player 2 was producing was optimal in gamma 2 star star. Was the optimal action regardless of what player 1 played. Here in this one, the action is Q2 star, which is optimal only when player 1 plays Q1 star. It is not optimal generically. It is not optimal in general. So there will be there are values of Q1 for which this is not the optimal response from player 2. So player 2 is actually, by ignoring information or whatever, is actually playing, irrationally in some sense. In the sense that he is being irrational in what sense? He is saying is that he is, for quantities other than Q1 star, there is no guarantee that he is actually going to be producing the optimal quantity for himself. But then as a result of that, what happens is the quantity that player 1 produces is Q1 star itself. And in that case, he has the optimal response available. So it's like this, that in a dynamic game, it will always happen that many possible paths can emerge from a game. Okay, player 1 could have played any potential quantity from 0 to infinity. Okay, this system could have evolved in many different directions, but what actually gets evolved is a result of the strategic decisions that players can play. So player 2 here is promising to play irrationally or carelessly or whatever word you want to give for it, for other values of Q1. But by promising to play in a kind of suitable way, but that promise is not totally arbitrary. It's a specific promise. It's a promise to play Q2 star. That particular value then forces player 1 to play Q1 star. And then once player 1 is playing Q1 star, Q2 star remains optimal anyways. Okay. So what happens is this promised irrational play at other points never really materializes in the gameplay. What happens? The gameplay actually sort of player 2 has effectively just navigated the game to the point where, voila, this is what I wanted to do. I am optimal at this for this particular strategy anyway, for this quantity anyways. Okay, so this is, you will see more examples of this. This is something that happens generically in dynamic games, that there will be paths in a dynamic game that in retrospect might seem irrational, but those paths never actually occur. And it is the irrational promises on those paths that decides which paths will actually occur. Okay, so I mean it's sort of, it's an enlightened form of rationality, in the sense that you are selectively being irrational to be rational at another level. That's effectively what a player is doing in a dynamic game. So player 2 is deliberately but very, very specifically being irrational. He is not being arbitrary. He is picking a very specific irrational response for other values of Q1, and that makes player 1 play Q1 star. Okay. Now, next time I will show you actually a game in which this sort of irrationality actually benefits player 2. Okay, so you might argue that, oh well, the earlier one seems like the more natural way of reasoning. Okay, we calculated the best response, we used all the calculus we know, etc., etc. But you will see that there are games where this second, where this sort of equilibrium is actually more beneficial to the player. So where ignoring information can actually benefit the player. Yeah.
If we finished our calculation in the beginning, this is exactly what we would arrive at.
Finished your calculation means?
As in finish the calculus by putting in it and differentiating again.
Not necessarily, because you have to assume a form, right?
Yes, there is
you have
form.
No. You have to see. So if you want to solve these kind of games, you have to first assume a form of dependence. So you will have to basically assume whether Q2 depends on Q1 or not. So you will if you want to use, since you brought this up, you want to do this with calculus, right? You will get things like partial derivative of this with respect to Q1. You will then have to fork from there. Is this equal to 0 or is it equal to something? Okay, and that tells you the form of whether something is being assumed to be a function of this or not. Yeah.
Nash equilibrium exists in the simultaneous game. Then any information flow from P1 to P2 is useless to P2, right? So the one
No. So it's not always the case. In this case, player 2, so not even in this case. Actually, the game that I will show you next, this time it's not that clear. But there are games where ignoring information is beneficial. There are games where ignoring information is not beneficial. See, when the main lesson is this. So now that we'll keep talking about information again and again. The main lesson is that when you have a single player problem, right, more information helps. You want to decide which route to take if you want to go from one point to the other. More information about the traffic, more information about various conditions, the road condition, more information about maintenance, breakdowns, etc. All of those things will actually help you. Okay, more information only gives you a better decision in the case of a single agent. Once there are multiple players involved, more information doesn't necessarily help. It is strategic sometimes to act like you have not heard anything. That is also a part of play. That could in fact benefit you as well. I am not suggesting you how to play in real life, but these are some of the consequences of game theory. Once we follow through the logic, right, you get all these insights which are really incredible. So this is actually you will see in fact the game that I will show you next time. This is a fantastic conclusion, that you can in fact act like you're crazy and then get others to act toe your line effectively. Yeah. Gamma 2 star star of Q1 star is equal to, gamma 2 star star was this thing, right? Yeah, is equal to Q2 star, that is right, because it is the response, right, to this to Q2 star. Yeah, but see, the thing is, but player 1 does not play Q1, player 1 does not play Q1 star. Player 1 plays Q1 star star, the double starred one, because of this dependence, right? This is where the anticipation is happening. He's anticipating how how player 2 would respond. Okay.